Hello and welcome to this UP42 tutorial. My name is Elizabeth, and today I'll be going over the things you'll need to know to get started with the user interface. Thanks for tuning in. In this video, I'll be giving a short tutorial on the steps to take to run the demo workflow. I've just activated the account from the console, and the first project has already been created. Open the demo project and see that there's a demo workflow within the project. You can have multiple projects which you can share with teams, and within each project, you can have multiple workflows. Open the workflow, and there are already blocks pre-populated into the workflow. Here, we have Sentinel-2 data for the European Space Agency, or ESA. This is a multispectral data set, and notice where it says L2A. This means that there's already been atmospheric correction on this data, removing any haze or distortion caused by the atmosphere. Then there's the super resolution algorithm. Because Sentinel-2 has bands of different resolutions, our data science team at UP42 leveraged deep learning to take low resolution images and derive higher resolution images, using our own network architecture design. Essentially, this algorithm yields super resolved images that are crisp and have uniform band resolutions. Now that we have a bit of background, we can save this and configure our job. Here on the job configuration page, you can search for a city or an address you're interested in, and then directly delineate your area of interest, or AOI. On the bottom, you'll get an estimation of the size of your AOI, and to the left, the coordinates are populated in GeoJSON. We can also, either after or before we draw the AOI, change the geometric filter, just like this. Just above the coordinates, notice there are some other parameters key to determining the data that we'll get. Next to time, we can adjust the date range. I'll just change this to 2019, and this will search for images from late 2020 to late 2019 that meet our other criteria, and yield the most recent ones of that time frame. I can increase the limit here to 3, and that means I'll get a max of 3 images returned from the state range, rather than just 1. Then I'll reduce the maximum percentage of cloud cover, and that should be good for the data parameters, and now we can go ahead and look at the algorithm's parameters. Sometimes algorithm parameters will need to be adjusted to your specific needs, but oftentimes it's just plug and play. Here, we just need to copy over the coordinates and paste them over into the proper spot, according to which geometric filter you have. Last, we'll change clip AOI to true, which ensures that the algorithm only runs on my AOI. Be mindful here that if I didn't turn on the AOI clipping functionality at this step, this super resolution block would run on the full scene. That's because the data block above isn't an AOI clipping block. It's yielding full scenes, so it's actually the super resolution block itself that's doing the AOI clipping. After all the configuration is done, notice the estimated processing time and credit usage. It's even broken down by the data and the processing components for full price transparency. It also serves the function that if you don't see these figures, you might need to make some adjustments to your parameters like this. Finally, we'll click Run, running this as a live job, so we can download the data and get results from the algorithms. Running the job will automatically take us to the job processing page. You may need to refresh the page in order to see the job's progress. Once it's done running, you'll see the breakdown of the credits you used, and you can click to download your results for visualization in your preferred geospatial software, whatever that may be. Thank you for watching this video. Let us know if you have further questions. Feel free to email me directly or contact our support team. For more ideas on how to upgrade your workflows, come visit us at up42.com.